Okay, I just deleted the component and repicked the component. This worked. Probably we didn't see it because it was too little, but you can see that we have our control points, and that's really interesting. So we need to now create the add and move position. So for the move position, first thing we need the index at which we need to change the position in our list. We need the new position, vector free position, and we need the point type. So for this we need to create a new public enumerator called point type, and inside of this we define 3 different type of point that will be previous, anchor previous, and following. So inside of this we can set the new position y to 0. Then we can start changing based on what is the point. So if the point is an anchor, as if it is a previous point, so previous with an else if, else this is a following point. So inside of this, if this is an anchor point, we need to move the control points with the same offset. So we define a new vector free called delta, and this delta is the movement from the previous position to the new position. So the previous position is what goes in front of this. Yes, so the previous position will be anchor dot anchor I, minus the new position. I don't want to go wrong, and then I can change this delta, so the anchor at I will be plus equal the delta, and same thing goes for the previous point. Obviously we need to define this as plus equal. So let's test this, go in the path editor and change this to fit the correct request. So the index, the new position will be the post right there, and the point type is an anchor, point type anchor, same thing goes right there, people's, and previous, and last is I have pose point type following. So let's see if this works. This doesn't work because, yes, I remember this wrong, and this is the opposite. So new position minus. So remove the component, replace the component. See, and now this works just fine, but we can't move the other 2 points, so let's fix this. the first thing to do is to change the point. The points should always create an 180-degree angle between each other. So what we're going to do is to take a point. The opposite point should be remaining at the same distance but with a different direction. So first thing is to calculate the distance. So with a float we can store the distance between just use vector3.distance and between the previous point at an eye and the anchor point at an eye. Order doesn't matter because this is a distance and it's always positive. Then we need to change the position of our previous point. Sorry, not the previous, this is the following, because it's the opposite point. The previous should be at the new position. Then we can calculate the direction going from the previous to the anchor. So for this we declare a new vector3 called direction. We need to normalize this vector to multiply this for the distance, and first we have to do the arriving, so the anchor, and then the other, that is the previous. Yes, this should be correct. And this is not a comma but a minus sign. So yes, normalized, this is the correct one. And for the following point we can change its position to an anchor position plus the new direction times distance position. This thing can be copied and pasted in the order by changing all these to the opposite, all these control points to the opposite point. So as we can see right there, let's update the script. And now if we move, this works just fine, and we can move around our points. Now it's time to add new points. So first thing to do is to go to the path editor and create the input system. So before we reach the input and create an input function, obviously, we define an event called GUI, and it's equal to the current event, and we search for the position of the mouse. That will be checked by the handles utility dot GUI to array, GUI to array, yes, of the mouse position, and we want only the origin of this. Perfect. And now we can check if we have the it's called if the type of the event is a mouse down, and if it is the button is set to 0, and sorry, button, sorry, and if it is to and if the shift key is pressed, if all of this is true, we can just change the mouse. We can just sorry, it's called add the point to the mouse position. So we go inside the path and create the add point function, declaring there the argument for the position and declaring the position y equal to 0. So first thing is to add the anchor point at the position. So position. Then we calculate the direction going between the previous and the following anchor points. So this is simply done by doing anchor and using the loop index function and the anchor dimension, so the anchor.count minus the previous to this. This is the next because the count is +1 in the array, because the count starts to 1 and not to 0, and this is -2 because we need the previous point. So count -1 is our point, the previous point is count -2. So we're just going to use another standard loop index function and use the -2, not 0, 2. Perfect. Now we need to calculate the distance for this. So the previous distance will be equal to the anchor point, the previous anchor point distance. So anchor point, we use the loop index to go to the previous one, so anchor point.count -2, and hour, and we need to use obviously the vector free.distance function without calculating this by hand, because we can calculate using the square root of both the value over the square root of the sum of the value of this, but this is just more complex in the code to see, to read the code, and we don't want that degree of optimization. So we use loop index only on anchor.count for our point that is -1. We do the exact same stuff for the following point, so we just copy this, paste this below, and instead of -2 we go for the count and stop, so it gives the next point, and use fdist as the name of the variable. So for the creation of the point, we use previous at an I, the previous dot add, sorry, and we add a new point at the position plus the normalized direction times the previous distance over 2, because we don't want the full distance. Same thing goes for the following point, so we just add the position plus the direction dot normalize times the following distance over 2, and the direction normalized of the previous should be minus, so it gives the correct one. And let's try this. So shift, I press, and this works just fine, creates a nice path without too much interruption.